Recently, a sub set out on a journey with 5 passengers to observe the wreckage of the Titanic. However, they have gone missing, and now there's an international effort to find them. This story has now blown up on social media, and everyone is wondering, what went wrong? Even though I happen to be an engineer, it doesn't take a degree to realize that this sub was poorly designed. Let's go over what is happening and how it could have been avoided. Given what we know, there are 3 possible scenarios. First, the submersible might have sprung a leak and may have imploded. Second, it may have made it back to the surface but not been found yet. And third, the sub might be lost underwater. Let's talk about scenario 1, where the submarine sprung a leak. Unfortunately, if this is the case, it's extremely likely that the craft imploded and all the occupants instantly perished. Nothing can be done but find and recover the bodies. However, I think this is unlikely to be the case. Even though a lot of the sub was designed haphazardly with game controllers and off-the-shelf parts, the hull itself was made with the help of NASA's composite team. So, if the hull didn't implode, this means that the submersible is likely out there somewhere. The 5 members on board are alive, but running out of oxygen as we speak. This leads us to scenario 2, where the sub may be lost but at the surface of the ocean. According to an interview, the sub had several ways it could return to the surface of the ocean. What could have happened is the crew lost power, inflated their airbag, and floated to the surface. But there is bad news. There is no way to escape the sub from the inside. You see, the entrance is bolted on with 17 screws from the outside. Inside, there's no way for the people to get out on their own. So, even if they were at sea level, they can't open a hatch to get fresh air. They must be found before their oxygen runs out. Because of this, we need to make it as easy as possible for the Coast Guard to find the sub. One easy fix is to add a beacon module to the submarine. It could be powered by a battery, so it's still operational if the sub loses power, and the module can contain several features that help locate it. First is an emergency position indicating radio beacon. Upon activation, it alerts an international satellite-based search and rescue system. In fact, my iPhone has something similar where it can send messages straight to a satellite when there is no signal. Second, this module can have a bright light that flashes an SOS message in Morse code. That way, it can be found by the naked eye if someone is in a plane or boat nearby. A beacon module on top of the sub is a straightforward and easy to implement solution that can drastically make it more straightforward to find the sub if it's lost on the surface of the ocean. But what about scenario 3? Where the sub is lost underwater. This is the worst case scenario. Water absorbs electromagnetic waves, so it would be impossible to use an emergency beacon of any sort since they use radio communication. GPS also doesn't work underwater. To make matters worse, once you get below a certain depth, the ocean becomes pitch black, so you can't simply rely on finding the sub with the naked eye. Luckily, there is a solution, and it comes in the form of sound. Water is a lot more dense than air, so sound can travel faster and further underwater. What the sub needs to do is make a lot of noise. In fact, as this video is being made, there are news stories with reports of hearing banging noises near where the sub went missing. Given the military's sonar capabilities, if the submarine is noisy, it can draw attention to itself and be found. The most rudimentary solution is to have the passengers bang on the hull with their fists or a hammer, but there is a smarter option. The same way we added the beacon module to the sub, we can add a sonar module. The purpose of this is not only to make sound, but to make a repetitive, known type of sound. It can be anything unique, but ideally it would be a series of repetitive clicks and chirps. The reason why is because rescuers can use signal processing techniques such as autocorrelations and cross-correlations to separate the unique noise from background noise. In fact, that's how GPS works. A GPS satellite antenna uses as much power as a light bulb, and the signal is weaker than background noise. But with some clever math, your phone is able to boost the signal above background noise to know your position. The same can be done with a lost submersible. If it makes a known repetitive noise, the sub can be found from a long distance away using existing technology. With the combination of the beacon module and the sonar module, the sub should be much easier to locate if it gets lost. Of course, the hindsight is 2020. It's much easier to come up with these ideas after a tragedy has occurred, since we have an example of what may have happened. Furthermore, finding a sub is half the battle. If it's deep underwater, there are very few manned rescue vehicles that can be used to retrieve it. At the time this video is being edited, the passengers of the Titan have 1 day left to be found before their oxygen runs out. I really hope they get rescued, and I hope the commercial underwater exploration industry learns from their mistakes.